We've seen that as an academic discipline, AI only began in 1956. Since then, it's had its booms and its winters. Symbolic AI was at the heart of the first two booms, whereas the current boom centres around machine learning. It's worth exploring these two varieties of AI a little bit further. Symbolic AI revolves around the idea that tasks that require intelligence can be solved by a computer processing symbols in a computer programming language or other representation that can be read and understood by humans. An early example of symbolic AI from the late 1960s is Sherdloo. Sherdloo was a dialogue system that allowed the user to issue commands in English for interaction with a world containing children's building blocks. For instance, in response to the user typing, "Pick up a big red block," the program, following a set of rules, interpreted the request and displayed the result of the action on the screen. Symbolic AI ran into difficulties when attempts were made to scale it beyond such simplified problem environments, known as toy domains. Subsequent work on expert systems, another approach to symbolic AI, tried to address this by developing tools and techniques that would help experts to build databases of rules for more realistic domains. However, these had limited success and proved too costly. An alternative way to address the scaling up problem was to build programs that could learn the required knowledge automatically. This brings us to machine learning. Some machine learning approaches still rely on symbolic AI, producing representations of knowledge that humans can read and understand. Other approaches, however, are described as sub-symbolic and do not result in representations that humans can consume. Decision tree learning is an example of the former, while artificial neural networks exemplify the latter. Unfortunately, progress on neural networks stalled at this point, and they experienced their own decades-long AI winter. They finally moved back to centre stage in 2012, when AlexNet beat the next best AI system in an image classification competition by a considerable margin. AlexNet turned out to be very good at identifying the correct labels for images. The remarkable comeback of artificial neural networks resulted from three developments in IT. First, the new availability of large datasets that could be used for training. Second, the new graphics processing units, or GPUs, developed for PCs and games consoles that were designed for parallel processing tasks. And third, new neural network algorithms that could exploit these parallel processing capabilities. In summary, AI can be divided into symbolic and sub-symbolic forms. Machine learning straddles both, but today's most popular machine learning applications rely primarily on neural networks, a sub-symbolic form of AI. That said, plenty of AI systems combine both symbolic and sub-symbolic methods and may be described as hybrid AI. Finally, let's look at the role that AI and machine learning play in the work of data scientists. A data scientist starts with data, often collected from several places, and uses it to answer a question, such as where and when the next forest fire is likely to occur. A data science lifecycle begins with data collection. This includes identifying relevant data sources, such as fire hotspots, meteorological data, and social media reports. Next comes data storage and processing, in which the data is cleaned and prepared for analysis. In data analysis, scientists will apply various methods, which can include AI, and more specifically machine learning, to find an answer to the original question. Finally, the insights gained from the model need to be communicated by interpreting the results and creating reports or data visualizations. In the projects you will engage with in this course, you can think of yourself as a budding data scientist, exploring a variety of AI and machine learning technologies to solve problems.